Okay, I found another short video on of a guitar factory tour. This one's Taylor's, and it's a lot shorter than the other one. It's about half the length. I think it's about 20 minutes. And Taylor's are interesting because they use all their guitars as bolt-on necks, and as you know, I'm using bolt-on necks, and I know their system's a little different than I'm using, but I'm interested to see how they do it. Hopefully they'll show us on this. But I'm not seeing this yet. I had a quick skim through it, but I've not actually watched it, so let's make a start.
Gosh, we have landed. We are in El Cajon, San Diego, to visit Taylor Guitars. We've got a whole bunch of stuff that we're going to check out. We're going to see a lot of their different manufacturing processes. We're going to play some guitars, we're going to spec some guitars out, and just going to have a bit of fun with it. This is James, whatever you want to call him. He's our new sales manager. Hello. Guitars. All good? All good. Let's take a look inside. Let's do it. Standing here with Jim. Jim's going to give us a nice factory tour of Taylor Guitars. We're going to check out a few different areas, see the whole flow of the factory and see what's going on, and just have some fun with it. So, you doing well, Jim?
Okay. Looking forward to this.
We've got about 8 buildings along our complex here. We're going to go through milling.
They all like to tell us about their wood coming in, don't they, and their wood stores.
Some steps of drying and conditioning and seasoning the wood. Because before you start building, you want to make sure that that wood is properly dried. Again, we're working with a variety of different species and they have different properties, right? So ebony is going to be different from spruce. Yeah. Every species is on its own unique drying schedule. So we go through really many steps of that. Once we get the wood kind of ready to go, then it goes into milling, and then we're starting to process those components again.
They were showing us at the Tecate facility. It takes weeks, doesn't it, to get some of that stuff?
It really does. You can't really fast forward that process. You have to kind of let Mother Nature do her thing in terms of moisture release. Over here we've got some guitar blanks, and you may know this already, but we do a 3-piece neck.
Yeah.
Our neck design is actually a patented design that we're really super happy with in terms of how it performs, how it allows the guitar to perform throughout its entire life. But you can see,
I didn't realise that. I know Martin do theirs as 1-piece neck, but they're doing a 3-piece neck with the headboard, the main neck, and the heel block. And again, that's very similar to what I do on mine.
All from the original segment of wood, and then we're going to come together later. And so when we're going through milling, especially as we get to this point, this is a cut that's already been laser cut. We have some inlay work. We are making sure that we get that surface down to the correct thickness.
Very smooth.
It's really going to be important in terms of tone, right? The recipe of a guitar is making sure it's everything from the bracing to how thick is that back, how thick is the top, everything getting optimized for the design that Andy's come up with. So with these kinds of machines, we can really very precisely control the thickness of those components. So that's what we're doing.
What have you got in your hands there?
This one, it's an experiment project. It looks like a Grand Pacific 517 model, but there's a couple of tweaks inside.
Tweaks going on.
There's always something. I mean, I guess that's one of the fun things about the life of a guitar maker is it's never exactly the same. And every time you go to make something, you're going to discover 10 other things that would also be interesting to try.
Yeah.
So there's no end to what you can make and do.
And a lot of the time, with a lot of these things, all these changes, massive changes that you can make to things are all under the hood, as it were. That all this time and effort that you put into making these changes, a lot of people don't get a chance to see today. But what a massive difference it kind of makes. And obviously, one of those the biggest things was the B-class bracing.
That was a pretty big change for us, and for a lot of.
Yeah, you mentioned that. Then there's 2 things that have been introduced. Andy's the new. He's been guitar designer at Taylor's for a while, but he's now the CEO as well, taking it from Bob Taylor. He's introduced a couple of changes. One is the bracing. They use now V bracing on some of their guitars, which is completely different to the X bracing that I've used. Something I want to find more out about, but I'm not quite sure. And the other thing is introduced on the lace guitars, I don't know if it'll be in this, is they've been using a bolt-on neck for a while, and they didn't glue the fingerboard down on the neck. What they've introduced in the last year or so is a bolt-on neck where you can adjust the neck angle as well as the neck bend. So normally you've got a truss rod to adjust the neck bend, but you can adjust the actual angle. Normally you have to take the neck off, sand it, and put it back on again for that. And I'm trying to find some technical data on that, how they do that, 'cause it's a very interesting idea, and not been able to see that anywhere yet. But yeah, hopefully we might see something on here.
We use lasers just after around 1995 or so when we were developing the Baby Taylor size problem solved. With most of our guitars, we inlay a decorative rosette on the side. Maybe we were looking at some other production techniques to make it a little bit more affordable guitar for folks. And so we started using lasers to etch a decorative pattern around the sound hole. I kind of opened the door to some other applications.
Yeah.
And now we use lasers a lot. We use them for cutting the actual shape of the top, back, sides. And then we can do other more intricate types of cutting work and inlays. These are a couple of custom or limited models that we've done over the years. So this is a Pelican inlay in which some of those pieces are laser cut. So what we'll do is we'll use a computer mill to do the routing work, to pocket, to hold those pieces. And then we have someone who will design that piece, and then we'll use to run a laser movement for it, and then can cut and see like that.
That's incredible work.
We'll have this is another a fun one to show folks. They're running horses. So same concept, but that's a couple different types of wood in there.
Yeah.
It might be maple and koa, so you get the lighter texture and sharper.
Yeah, that's great.
So the lasers are great because we write the programs. So they're super accurate. You don't have a tool bit that's going to dull. You're not going to kick the wood. It's safer than using other types of saws. And again, you build efficiencies in the process.
So the laser will be used for like a
I don't think I'm going to get a laser.
And stuff on that bit on the fretboard. Yeah.
Well, in fact,
So
so here's one. That's another. And this is kind of cool because it's a little bit more of a fluid design.
Yeah.
So what we'll do is we'll actually do the inlay work first, and then we'll do cut the fret slice.
Really.
I want the dynamic range of a great instrument, and that's what makes it so it feels responsive. If I hit it hard, and I want some muscle behind it. If I play it delicately, I want a broad,
That's
responding voice. But at the same time, I want the kind of note response that might seem like a good piano. It is a difficult instrument, and it's kind of easy in that you have a set of strings for one pitch. So there's a lot that you can do to manipulate that. Because you press a key, you get that note. That's what you get. And so you don't have to have multiple pitches coming off of one string. You don't do that. And so you can regulate the piano pretty accurately. But I want that kind of feel on a guitar where if I play minor 9, and then major 7, spicy chord, but in a good way.
When you have that next chord in, it's better.
Like, how do you do that?
Yeah.
So we wanted to bring you into the Rosette next. We want to talk about some of the processes involved in doing many different rosettes. How many rosettes? This is Garrett, by the way.
I guess
How many different rosettes do we do?
currently we have just one standard rosette for each model line. So from 10 series all the way to PS, about 10.
Okay.
We also have customs, those come through, and this is one of the only rooms in the factory where we still do process by hand. So we decide the lasers and machinery that supports parts like this come out of the room, and each one of these is just installed by hand, cut by hand, and they're all custom fitted. You can see the rosette parts here on the wall. They're all twin length, but they all get installed by each one of these people.
It's actually a great point because we sell the lasers. We're going to see computer mills. We're going to see robotics, and so there's a lot of high tech stuff that happens here in the factory. But it's a marriage of that kind of technology and craftsmanship. People are still very much involved in the process, and like you say, rosette work is really a prime example of that detail work that's done.
And they'll take the time. They'll make sure each one of these joints is flawless before it moves on.
something. Okay, here's something interesting. You can confirm this, but I think Andy Powers told me people sometimes ask, "Is the rosette purely decorative?" And Andy always makes them saying, "No, it actually has a practical function, and that is to help prevent the top from cracking along the end grain. The end grain being, I think, where the neck and the bridge in that area, because from what Andy was saying, the top in those areas along the end grain, that the top will either gain or lose moisture at a faster rate than the edge grains. So that really can help to prevent cracking on it.
Yeah. So after we remove the material from the top there, the balance sound holes on a few of these models here actually help support the top. So one of the old school techniques is to soak the wood. To paint on the wood, it can be a few minutes to maybe 30 minutes or so. And then she's hand bending this around a pipe bender that's about 400 degrees. So it takes a skilled craftsman to know exactly how much pressure and how long to keep that material on the bender. And I'll remember this, you have to do for every
Hand bending the inlay.
It takes that appointment.
Not something I've thought about, but it's probably something that's one of the reasons why mine broke on me when I was
all these little
doing
parts
some of the
in
last
here
guitar.
our laser machines cut out, and then we install it just like a little puzzle. It might look pretty challenging, but they're fairly easy.
Like as a musician, I've always played in a variety of styles.
Yeah.
And I love different instruments. I love that they are different. And I love that every musician is different. We don't hear things the same way. We don't play things the same way. We don't want the same result out of every instrument. And so when I look at our guitars, I think I want to be deliberately building a wider variety of sounds because there's a place for it to go. It's not just another, just a line item on somebody's sales price list
Just
kind
not
of
another
thing.
skill,
It's
yeah,
like, no, man, I don't do skills and build guitars. You know, there's a place for these things to exist, and it's good that not everything is for every player.
Yeah.
One of the things that impresses me about Taylor is their sort of some of the key people in the design team are actually musicians. Andy's I've seen him play guitar on videos and things like that. And he's a designer and he's running the company now. It's a newish company, only started at some point in the 70s. But they're innovating all the time and they're always trying to improve. Whereas I think companies like Gibson have kind of given up on that. They just kind of reissuing old things and relying on their name. Martin, somewhere in between. I think Taylor are doing a better job than Martin at the moment as well. Although Martin still do a very good job of guitars.
Other person, it's really hard to regulate that pressure to get a nice consistent shine on a gloss finish. So we've actually been using robotic buffing units going back to like 2001, so over 20 years now. It's obviously the systems have evolved over time, but we love the consistency that buffing methods require and the equation. Anytime we can use machines and tools to take the physical strain off of people, allow them to focus on other aspects of craftsmanship that others exist. This is an area where it might be good to talk about that patented neck design that we saw earlier, because I think to appreciate the Taylor neck, you kind of need to see the body of the guitar, also to see how the two of them relate to each other. And so, we use this as an example. I'm going to pull this out. This looks like it's a Builder's Edition 324 CE. So, I mentioned we do a three-piece guitar neck. So we've got the neck head, we've got the neck itself, and then the heel. All those components cut from the same original segment of wood, but then cut into separate pieces and then glued together. A couple of benefits. One up here where the headstock meets the neck. If this were a single piece, a lot of times this is a vulnerable place, right? It's hard, it's knocked over something, it's likely to crack, or the stress at that angle can often cause some cracking, leaking, whatever. So we strengthen the guitar neck at that end. This is where the magic happens, I think, down here, because typically you hit, if this is 14 fret neck, which it is, you get to that 14th fret, typically the neck itself lands on the heel, right? So you just have the fretboard.
You see where they've got the, beyond the heel, there's a block of wood under the fretboard, as it's pointing to at the minute. That's cut away into the block of the guitar on top. So rather than gluing the fretboard down, you can screw up into that through the block inside the body to lock it in place. So it's not glued on at all. And that's a kind of very interesting idea, because you can just take it off, and then they've got shim packs to set the angle. This is their older neck design that they did about 25 years ago. So in terms of that, that's almost something you can do yourself as a guitarist without taking it to a guitar tech to have a neck reset, which is quite an expensive operation. The new one is even easier, but I'm not sure we're going to see any of that. You see the pocket there, it's where it's cut through the front of the body. It's almost like a neck on a electric guitar, like on a Stratocaster or something like that. Although it's got a heel, but so it's an angled joint. But and they're in effect using a tenon as well with their bolted neck.
That guitar settles into its environment, it changes a little bit. That that neck may need a reset. But guess what? With a Taylor, you can basically, a technician can go through the sound hole, basically unbolt that neck in a minute.
One last little question. Yeah. So when you come in every day, you've got all these cool things and all these different projects that you're working on all the time. How do you kind of decide what's like, this is what I want to work on right now? Because you must have so much going on in your head at all times of things like, I need to fix this, I need to do this, I need to see this project through, and
with my last guitar, although it's a bolt on, the fingerboard's still glued to the body. So if you need to take the neck off, you've got to heat the fingerboard really to soften the glue to get that apart, and then you can disconnect it, which is easier than having to soften the glue in the dovetail when you've got a glued neck as well, which is what guitar techs have to do to reset a neck on them.
Deliberately scheduling about some time. This is something that I think should someday exist.
sooner rather than later kind of thing.
Or later rather than sooner sometimes. So I think it should exist. I'm interested in it. I just don't see where it goes. And sometimes it's an idea where it goes, I wish I hadn't built that guitar because now I really want it to exist.
Now.
I can't manufacture that guitar. Because that is a possibility that you could build something that I can't regularly do that. At least not yet. Not until I invent X, Y, and Z to be able to make it. So there are a lot of things.
Don't think we're going to see anything on the new neck design. We've also not shown us anything the inside body of the bracing plan that they've got, the V-brace. So I'll have to look for something else on that. I have seen some drawings of that. I don't think I've actually seen one. I've got, apart from the next one I'm building, I've actually bought, because I didn't get the tone wood I wanted because it sold out, and then some more came in after I'd ordered that. So I've actually ordered some tone wood for 3 guitars now. So each one's going to be slightly more complicated than the last. So the next one will do some inlay on the headboard. Then I think the one after that is going to be a cutaway, or one of them is going to be a cutaway, and then one of them is going to, I want to get the neck more so that I don't need to glue it. So, and I'd like to know how Taylor are doing the new adjustable neck angle on the guitar, if that's something I can use. I'm pretty much assuming that's going to be patented though for the time being.
So upstairs, the top and the back above the bracing process. And then the sides are also got automated side menus up there that take care of that part.
But if I can do it's a straight bolt on neck, I don't think there's any amateur or bespoke builders at the moment building them like that. They're building bolt-on, tenon bolt-on necks, but they're still gluing fingerboard.
It's a pretty short drawing time.
Guys, we had a run down earlier showing us how they do that armrest.
It is so much handwork.
It really is a lot of handwork. We've got this here's a nylon.
Oh, cool.
So this is got the fan
There's
style.
an arm bevel on that one.
With the nylon, less spring tension, so racing pieces. So obviously,
That's a fan brace. So, yeah, nylon string
Thanks
guitar.
much, you guys. Really appreciate it.
Okay, one of those guitar tops that was in the rack was a V one. You didn't pull it out, it was one below the one that pulled out. So I might try and, when I edit all this together, I'll try and highlight that.